Hello and welcome to Tribe Topper. I'm Sonal Gupta, and this channel is about increasing your understanding of physics. To clear your concepts, subscribe to our channel and click the bell icon for latest updated videos. In this video session, you are going to learn about the intensity variation with double slit. So this is a pattern which we have picked up, which shows that how the intensity varies with double slit. So when you have light passing through a double slit, how the two waves interfere and diffract, and this is how the intensity changes. If you see carefully, the middle one, the central one, is the brightest spot, which is known as the central maxima. Then you have a little less intensity, and gradually your next maximas, which you can see very faintly as red lines. Of course, it is they are separated between them by dark fringes also. So the red lines are very faint ones. So the intensity, that means, goes on decreasing on either side of the central bright maximum. So let's see how this pattern changes for a single slit and a double slit. So this is the first slit. You can see how the relative intensity changes. How is it varying for a double slit interference pattern? So this represents the double slit interference pattern. There is no diffraction happening yet. We are only considering that the waves which are coming from these two slits, how they interfere. And when they interfere, they give rise to bright and dark fringes. So the relative intensity is almost constant. So relative intensity here is constant with the angle when you go from the central towards the sides. Like this is the angle, you go here or you go here, that angle. So with that angle variation, the relative intensity is almost the same. But if you look at this next figure, what do you find here? This is showing the variation of relative intensity with angle for a single slit. So here your relative intensity is changing with the angle, but this time it is not for double slit, it is for a single slit. So for single slit, you see the central bright maximum has a relative intensity really high. This is the highest intensity that you have, which corresponds to the central maximum. But then it just falls to a very low value. So the next maxima is going to be a very faint one. See, this is the relative intensity. That's the height of these waves. So which indicates that your relative intensity drops sharply with angle when we talk of a single slit. But this is a single slit diffraction, not the interference. The first one was a interference from the double slit. This is the diffraction from a single slit. When I combine the two effects, I get this type of a wave, where you see that the distance, this relative distance between these waves, that remains the same, right? But the intensity, the value of the relative intensity, decreases for an angle beyond 10 degrees. So you do get a maxima, but that is of a lower value. So this figure is showing a superposition of the two phenomena, the superposition of the two effects. And what are those two effects? Number one, interference from double slit, and secondly, the diffraction that happens from each slit. So when those two effects, they superimpose, you get this type of a wave, which is also known as a modulated wave. So the fringe spacing does not change here, but the bright fringes which are occurring beyond this angle of 11 degrees, they have a relatively very low intensity. Right? And for as far as mathematics is concerned, we have the same mathematics which you have already done in topic 4. So the separation between the two fringes is given by lambda d by d. So S represents the separation between the fringes, and lambda is of course the wavelength of the light we are using. Capital D is the distance between the slits and the screen, whereas small d is the distance between the slits itself. Right? So this is how the pattern or the wave graphical representation changes when you combine the two phenomena. So that's all for this video session. In the next video session, you're going to understand the multiple slit interference. Thank you.